Okay, howdy, welcome back. So we're going to get into functions now, specifically writing them in C++. So functions, you're going to be essentially just a name sequence of statements, and we'll get into some of their more interesting features as we move through the course. So I'm not going to talk about things such as function overloading right now, or different styles of function argument passing. For now, let's just consider the basic syntax of a function definition. I think we've all encountered the main function. It's our gateway entry point into any C++ program. Following the how a declaration is kind of composed, we can see here that a function definition is going to, at least the first line will follow a similar result. We're going to have a base type, in this case, the function return type. And will be followed by the function's name. In the case of the main function, that was just main, followed by a parameter list, which will specify the parameters to the function. These will be initialized with the arguments that are passed to it. For now, we've introduced main without any sort of parameters. We'll see when we start talking about command line arguments that there are other ways to go about this. But directly preceding the list of parameters is going to be the body of the function. And this is going to be that sequence of statements that is executed when the function is invoked. So a couple of things to keep in mind here as we're crafting our functions is that the base type is, again, going to specify the return type of the function, the type of the value that we're getting back upon execution of this named sequence of statements. If our function is not going to return a value, we can specify void as a pseudo return type for a function to communicate that no value is going to be returned to the caller after the function has been executed. The function's parameters are going to be specified in a comma separated list enclosed in parentheses. So if you had, say, two double parameters, it would be within the parameter list, double X, double Y. It's just you're listing out the parameters, type followed by identifier, and then a comment to separate one from another. As shown with the main function, a function's parameter list can be left empty, but it cannot be omitted. So you can't write something like int main, because what is that? This is going to be a declaration of an integer type named main. To signify that it is a function and not a declaration of, say, an object in this case, you need that parameter list. So don't forget it. When we're writing our functions, they're always going to have two parts. A function declaration, which will be terminated by the semicolon, and this follows the form of a declaration that was introduced in the object's value in type lecture. We have that base type followed by an identifier and a declarator operator. In this case, it's going to be the parameter list, which is here populated with a single parameter, an integer identified by X. We're also going to write a function definition. Note here, this is where the function body is actually specified. So in this case, we have pretty much what we had in the declaration up to that semicolon repeated. And then opposed to terminating this in a declaration, we actually go ahead and define it by providing a block that is going to introduce the sequence of statements that are executed when this function is invoked. Here, square is simply squaring the value, the integer value that was passed in. So we're multiplying X by itself. That's equivalent to raising it to the power of 2. And we return that value or the result of this operation to the caller. So whoever's using this function. So why do we need both this kind of function declaration and definition? Why is the function definition not enough? Why do we have to go through the process of writing a declaration too? Well, just to begin, we're going to focus on what the declaration helps us with, what's it's affording to our program. In C++, we have to introduce each name in our program prior to its use so that the compiler can ensure that we're using it correctly. I can't just write I and assign it some value as 7. I have to introduce I before I can use it. So I have a declaration, int I, and for the primitive types, I'm always going to initialize it. Remember, that's kind of our big rule here. But now C++ knows that I is an integer, and it knows which sort of operations are allowed to be invoked on it. Likewise, if I had double, and I assigned it the value of 3.14, if I were to write something like d mod 2, the compiler is going to catch this because modulo is not defined for objects of type double. So introducing the name allows the compiler to tell us or to recognize potential misuse of objects of a specified type. Likewise, for a function, what it's going to tell us is, and do be aware of implicit conversions, but how that function can be used. For instance, if I had something like square 5 mod 2, that's going to be a valid expression. Had this function returned a double, the compiler would have gone, oh, hey, they're attempting to return a result because that function evaluates to a double mod 2. So I'm going to go ahead and complain and not allow you to compile your source code in this instance. But this, because it's returning an int, the compiler is happy. It knows that, okay, hey, this is a totally valid operation. We'll let them go on their merry way. So all information needed to call a function is also going to be shown in the first line. This is going to be extremely helpful for us because if we're interested in using this function, we don't have to open up a file that has just this header followed by a long definition, which we're not concerned about because we want to use it. So just looking at the first line of the definition, int square, int x, okay, that's all we need to know to use it. And we programmers don't typically check the function implementation before we use it if we're using a library with a good reputation that's been proven and substantially tested. So instead, we're always seemingly more interested in how we use a function. So how do we call it? What value does it return? And probably what does it do? But I mean, at that point, if you're using it, you probably have a good idea. So in C++, function declarations provide the information we need to call the function and for the compiler to ensure we're doing so correctly. And I point out here, don't forget about implicit conversions because I can call square with 3.14. I could call square with a because these two types, double and char, have implicit conversions defined for them to type int. So essentially what would happen is these would be essentially what we have in these cases is a is either equal to 3.14 or a in this case. And notice that follows exactly what you've seen before because this is what's happening. And as we'll see later, the semantics of initialization are going to be identical to that of argument passing and vice versa. So anytime you see the initialization of a parameter, I guess that's int x, just think about it in this way, how you're already familiar with. Because the semantics, the meaning of the initialization of the parameter is identical to that of the initialization of an object in this case. So again, in terms of a declaration, so this is not a call, this is the introducing of square. It is terminated with a semicolon. Now to use the function, we simply write out the function declaration in our file. So if we wanted to use square in main, we'd write something like int square, int x, and notice how we're doing this before it's being used. Then we could have something like int main, that would get through one of the stages of the compilation process. And we'll get into, okay, well, how does the definition get linked up to that? So don't worry about that as much. Just understand the compiler on its kind of first pass going through it. It can go, okay, there's this name square. okay, it takes an integer, it returns an int, and then, okay, I'm seeing that name being used in my function main. It's being used correctly. I'll worry about hooking that up to a actual function call a little bit later in the process. Because the first time through, I'm just concerned with, hey, is the syntax correct? And are these types being used appropriately, or type checking? But more on that in a little bit. It's probably beneficial to at least think about that a little bit beforehand. Now, the motivation for kind of where our function declarations are going to live and where their definitions are going to live is going to be introduced in a way that follows C++ conventions. Right now, I'm kind of just going to say you need to do it this way. Don't concern yourself with precisely why. Though once we talk about the compilation pipeline, we'll see exactly how these two different files are utilized and the implications of having, say, the definition of the function in its own kind of source file and the declarations in their own header file. So instead of writing the declaration out each time we want to use it, for instance, and it has to be done kind of once per file, and we'll get into more complicated programs where you're working with multiple files. So instead of having to do this kind of at the top every single time, and if you do write it out every single time, you're kind of doing the same copying and pasting thing that you were doing with a block of code. You could mistype the declaration, and that would run into some issues when you go to actually compile your source code. But for right now, we just want to avoid having to write it out, excuse me, explicitly. So we're going to go ahead and write it in a header file. So this is going to be a new file. So just like in Microsoft Word, where you can create a new document, we're creating a new document here. It's going to be called a header file. The extension is going to be .h. The name is going to be descriptive with underscores to separate out different words within it. So in this case, my math ops, short from my math operations. And then the actual body of the function, or sorry, of the file, document, whatever you'd like to call it, is here. We will get into what these are when we're talking about compilation. They're known as header guards. You don't need to worry about them right now, but I promise, illustrate exactly why they're important and why we need them a bit later. But for this point, simply replace, for your own files, if you were to do this, notice that simply follows with what the actual name of the file is. And this is essentially saying, if I haven't seen this file before, say that I have, and then include some text and move on. But we'll get into that later. Here's what's important. Here's our declaration. Notice there's no definition in this header file. All it is the declaration saying what square is. It's a function. It has a single parameter, an integer object, and it's going to return an integer. Now back in main, what I can do, and we'll get into precisely again what an include statement's doing later on, but for now, just think of it doing that kind of copy and paste process for you. This is essentially this statement here, pound include my math ops, is going to essentially go out and pull the contents of that file. So this declaration here, I wonder if I can go across pages. Cool. Into this actual source file. So what that means then is, as we get into main, we know exactly what square is, how it can be used, as well as the compiler knows whether or not we're using it correctly. So I simply pound include my header file and I go on, okay, here's a main, I'm going to square some value that I'm going to ask the user to provide through standard input. I'll go ahead and pass that value to my square function, and I'll store the result in square number. Now, we haven't defined what the sequence of statements are to be executed when our function square is invoked. Right now, all we've said is, hey, there's this thing called square, here's how you use it, and we went ahead using it. Well, at some point, we have to say exactly, well, these are the sequence of statements that are to be executed when this function's invoked. So the function is going to be defined. That is, our function definition is going to be provided in a source file that's going to have the same name bearing a different extension corresponding to our header file. So here we can see that we're going to create a new document, mymathops.cc. It's a source file, so it's going to contain definitions of different entities. And then we have the header file with a corresponding name. And it's very evident that these two go together because they have the same names but different extensions. And this is C++ convention. The first thing that we're always going to do, and we'll get into why this is important when we talk about compilation, is just pound include that header file within our source file. And again, this is the contents of mymathops.cc. Directly after that, we can begin defining these entities. So we're going to say here that square, it's going to be a function with a single integer parameter, returns an int. And when it is invoked, we are executing just a single statement. In this scenario, we're returning the value of x multiplied by itself to the caller. So let's just break down the differences between a header file and a source file at this point. And again, we haven't talked about the development environment just yet. There will be activities that you'll be completing that essentially will do the compilation process for you, but we're going to expect you to structure things in this manner. So there's likely going to be an activity on this page which has like main.cc and then maybe, you know, mymathops.cc and then another tab for mymathops.h. And we'll likely tell you to go ahead, you know, structure things correctly to write some sort of mathematical operation. You'll go through the motions, you'll hit the big, whatever color button it is to run that, and then you'll check it against whether or not you've done that correctly. When we get into the compilation process, we'll kind of reveal what's happening when that button is pressed, and then also how you'll go about compiling multiple files within your development environment. But for now, let's just talk about the files and just understand what goes where, and we'll get into how it all links up soon enough. So header files, they're going to contain all the information we need to understand how to call a function or functions. We don't know and often don't care how a function is going to be defined as long as it's working correctly. So if we want to see what functions we are able to use, we can just open up the header file and have seamless access to this information. It contains all the information as well that the compiler would need to ensure we're using the name correctly. So we can simply include it where we want to use the functions. As long as our function has been declared before the name is used, we can use that function. So one of the cool things about this is it completely removes the distraction of what a function definition would mean. I mean, if we have a series of declarations, it's very clear, you know, what the names are, how they're to be used. If we had a full definition in this file, there'd be a lot of scrolling because we'd have to hop over the definitions to see, okay, well, what's the next name that's going to be used? And then we'd also see that if they were defined, it never define a function in the header file until we tell you to do so. And we will when we get into function templates. But that aside, that's a special case. Never define the functions in the header file. That kind of gets around this C++ idea of separate compilation, which we will talk about again towards the end of this week. Now, the corresponding source file, again, same name, just different header, different extension. The idea, again, making a relationship that, okay, this source file corresponds to that header. So we can then, you know, very easily expect that, okay, the definitions of those entities that were declared in the header file can be found in this corresponding source file. So it keeps the distracting function definitions out of our sight since we aren't really concerned with them. If we need to go ahead and update the implementation, we can do so in this file. And we'll see again, this will help enable separate compilation, which we'll get to shortly. So I want to close out with just a very primitive discussion on what happens when we call a function. We'll get into this more detail when we introduce the stack, but that's to come. So let's just say, okay, assume that we have the header file and the source file set up correctly. We've compiled everything correctly down into an executable, and now we're going to run our program for the first time. So we begin in main. Let's consider a few things that happens during a function called a square. So assignment or declaration in this case with initialization is going to be right to left. So this gets executed first. What's happening? So we're going to take that 11, the argument to the function, and we're going to use it to initialize the parameter x. So squares int x is going to be initialized with 11. And again, the semantics of argument passing are going to be identical to that of initialization. So you can literally take the argument, put an equal sign after the parameter, and it looks like typical initialization that we're familiar with up to this point. Now we're going to have to transfer control into the square function. So our execution of main will be paused. The sequence of statements that are defined to square will be executed, and then eventually the returned result is going to be transferred back to the calling function. So we will pick up where we left off in main, and that return value in this case will be used to initialize square 11. So I lied. There's, I guess, one more slide that I want to get through. I'm trying to interdisperse different components of the C++ style guide from Google as relevant through these lessons, because again, we're expecting you to follow the style guide. So function names, unless specified otherwise, and we will see an exception to this rule when we get into classes, should start with a capital letter and have a capital letter for each new word. If a function exceeds approximately 40 lines, you should really break it up into multiple functions if at all possible. Definitely minimize the use of vertical white space. Don't use blank lines when you don't have to. A blank line within a block of code serves kind of like a paragraph break in prose. It should be used to separate thoughts. So group the stuff that kind of goes together, use a white space to then get into a new kind of separate thought. Every non-trivial function definition should have comments immediately preceding it, describing what the function does and how one should use it. This would be important. This would be done in the header file. It would allow myself or you to open that up and go, okay, here's the functions I have available. And then there's also some commentary describing how those functions can be used.